All right, let's talk about building a PWA lab. We're going to set up a totally secure local development environment right on your Windows machine. Look, if you've ever been stuck trying to test those advanced PWA features on your phone, but it's all running on your PC, well, this explainer is exactly what you need. So let's get this lab built. So you know the feeling, right? You've built this awesome PWA. The basic stuff is working perfectly, but then the second you try to do something cool, like register a service worker or fire off a push notification, it just breaks. Nothing. It's a super common and honestly really frustrating problem. So what is actually going on here? Well, the answer really just boils down to one word: security. You see, modern browsers are incredibly strict, and honestly, for good reason. They absolutely demand a secure HTTPS connection for all the powerful stuff. We're talking service workers, push notifications, geolocation, you name it. All those features need to see that little padlock in the address bar, even if you're just messing around on your own local machine.
Okay, so here's our game plan. First, we'll break down the core problem. Then, we'll actually build our server. After that, we'll lock it down with HTTPS, teach our devices to trust it, and finally, we'll put our brand new PWA lab to the test.
All right, first up, let's talk about the big problem here. You know, localhost is awesome for testing on your main computer, but to your phone or your tablet, it's basically invisible. They can't see it at all. So if you want to really test your PWA properly, you need a server that all your other devices can actually find and, more importantly, connect to securely. Okay, now for the fun part. Let's actually build this server. We're going to start right from the ground up. That means a little bit of network configuration, installing our WAMP server, which, by the way, is just a neat bundle of Windows, Apache, MySQL, and PHP, and then we'll tell the Windows firewall to, let our other devices in on the fun. First things first, our server needs a permanent address on the network, and for that, we need a static IP. Just think of it like this. If your home network is a giant parking lot, a static IP is your own personal reserved parking spot. No matter what, your phone will always know exactly where to find your server. So to reserve that parking spot, you're going to have to log into your network router's admin panel. Usually, the address and the login info are printed on a little sticker right on the router itself. Think of this as the main control center for your entire home network. Okay, once you're logged in, you need to hunt for a section called something like DHCP server settings. This is the part of your router that normally hands out temporary IP addresses to all your devices. We're going to go in there and tell it to give our computer a permanent one. So yeah, it really just boils down to these 4 steps. You log into the router, find those DHCP settings, find your computer's unique MAC address, which is kind of like its digital fingerprint, and then you create a reservation that says, hey, this computer always gets this specific IP address. Simple as that. All right, with our network address all locked in, it's time to install the server software itself, WAMP Server. Once that's done, we have to tweak the Windows firewall. This is kind of like telling the bouncer at a club, hey, my phone and my tablet, yeah, they're on the list, let them in. And here's the best part. Checking if it works is super simple. Just look for the WAMP icon down in your system tray. If it's green, you're golden. That means all the services, Apache, PHP, the database, are running perfectly. If it's red or orange, well, something probably needs a little nudge. So why did we even bother messing with a firewall? Well, this really spells it out. Before we added that rule, it was a one-way street. Only your PC could talk to the server. But after we made that change, any device on your network can connect. And that right there is exactly what we need for real-world testing. All right, let's move on to enabling secure connections. Right now, our server is up and running and our devices can see it. But it's only speaking insecure HTTP. So now we have to teach it how to speak HTTPS, the secure language of pretty much the entire modern web. And the good news is, WAMP makes this part surprisingly easy. All you have to do is click on that little WAMP icon, go into the Apache menu, then into Apache modules, and just check on 2 things, SSL module and Socache SHMB module. Literally just a couple of clicks, and boom, Apache has the core engine it needs to handle SSL. Okay, the last little tweak here is to pop open a configuration file and tell Apache to start listening on port 443. Just like port 80 is the default door for all regular HTTP traffic, port 443 is the official, universally recognized VIP entrance for all secure HTTPS traffic. All right, section 4. Here's where we make our server trusted. See, our server can now handle a secure connection, but browsers don't trust it one bit. We need to create our own security passport, what's called a self-signed certificate, to prove our server's identity.
Now, this can be the trickiest part of the whole process, but don't worry, we're going to walk right through it. To do this, we're going to use the command line and a powerful tool called OpenSSL. Our very first command generates a private key. Now, this is the super secret foundational piece of your server's identity. You have to keep this file safe and never, ever share it. Now, using that private key we just made, we run a second command. This one generates the public certificate. This is the actual passport that your server is going to show to browsers to prove who it is. It's got all the public info, like your server's local name. So when all is said and done, you're going to have three really important files. You've got the private.key, that's the server's big secret. Then there's certificate.crt, which is the public passport for Apache itself. And finally, mywebsite.crt, which is a special copy that's formatted just right for us to install on our mobile devices. Okay, so quick heads up. The very first time you visit your new secure server, you're going to get a big, scary warning page. Do not panic. This is 100% expected. All the browser is saying is, hey, I see this passport, but I've never heard of the person who issued it. Our next job is to teach it to trust us as the authority. And now for the magic trick that makes mobile testing possible. We have to install that certificate directly onto your phone. So you'll just transfer that mywebsite.crt file over to your device. And then you'll need to dig into your phone's security settings and install it as a trusted certificate authority. And once that certificate is installed, check it out. The big scary warning is gone. And instead, you get that beautiful, satisfying little green padlock in the address bar. Your phone now 100% trusts your local development server. Success! And that brings us to the final section, the test run. We've done all the hard work setting this thing up. Now it's time for the payoff. Let's actually verify that our PWA features are finally working over this new secure connection. Hey, remember that line of code that was failing before? The one that was trying to register our service worker? Well, now that we're connected over HTTPS, the browser's security rules are totally satisfied, and this code is finally allowed to run. And here it is, the moment of truth. Pop open the developer tools in your browser, take a look at the console, and you'll see this beautiful message, Service Worker Registered. That right there is the proof. Your Secure PWA Lab is officially open for business. So there you have it. A complete, multi-device, totally secure testing environment for building the next generation of PWAs, all running from your own machine. The whole setup is ready to go. The only question left is, what are you going to build?